Hello everyone. On this video we will be covering triple integrals and cylindrical and spherical coordinates. Okay, so starting off with our cylindrical coordinates. Of course, that's the triple integral xy z with respect to the volume. Now, in order to convert these to cylindrical coordinates, remember that x is equal to r cosine of theta, y is equal to r sine of theta, z is just equal to z or f of xy, and x squared plus y squared equals r squared. Okay, you're going to have to remember all of those because they will come in quite handy. All right, so yeah, from theta 1 or theta number 2, and the integral from our theta function, the first one and the second one, and the integral from our function of theta cosine, our cosine of theta, our sine of theta, and our second function of our cosine theta, our sine of theta, the function of our cosine of theta, our sine of theta, z times your r, that's dz dr d theta. Okay, don't forget to multiply that r. Okay, so this is your triple integral and cylindrical coordinates. All right, so quick note is that you can change up your orders of integration, okay, like we did on the last video. Okay, so there are 6 possible orders of integration. Okay. Thing is, they're all equal. No matter how you rearrange these, they all will give you the same answer if done correctly. Okay, so you have dz dr d theta, dz d theta dr. You have dr dz d theta. You have dr d theta dz. You have d theta. Don't need that. dz dr and d theta dr dz. Okay, so those are your 6 orders of integration. And again, you can use them in whichever order you like. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and go to our first example. Okay, so let's say, for example, we wanted to evaluate the integral from 0 to pi over 2, the integral from 0 to 2 cosine squared theta, and the integral from 0 to 4 minus r squared, r sine of theta, dz dr d theta. right, so I'm just going to go ahead and rewrite this. So from 0 to pi over 2, from 0 to 2 cosine squared theta, from 0 to 4 minus r squared, r sine of theta dz dr d theta. Just like before, we're going to start right in the middle. Okay, with respect to z, remember all of that's treated as a constant, so with respect to z, we have from 0 to pi over 2, 0 to 2 cosine squared theta, and that just becomes z r sine of theta. And that goes from 0 to 4 minus r squared, or z equals 0 to 4 minus r squared, and our dr and d theta. All right, so we go ahead and plug in 0 to pi over 2. Let me fill that in first. So from 0 to 2 cosine squared theta, you plug in 4 minus r squared times r times sine of theta. You will get, I'm just going to put the r on the outside, r times 4 minus r squared times sine of theta. You plug in z equals 0, that's just 0, so we're good there. And that's dr d theta. Okay, so we can go ahead and integrate this middle one now with respect to our r. Okay, so we have the integral from 0 to pi over 2. And if we go ahead and distribute that, we'll have 4r. So the integral of that is r squared over 2. So 4 divided by 2 is 2, so that gives us 2r squared. We distribute this one, you get r to the third. So if you integrate that one, is r to the fourth over 4. That's minus r to the fourth over 4. And that's from 0 to 2 cosine squared theta. And that's sine of theta d theta. Okay, so that's just still there. Okay, so if we plug in our 2 cosine squared, that's 2 times 2 is 4. So we have 4 times 2, which is 8. And remember, you have 2 cosine squared, and that will be squared. So 2 cosine squared times 2 cosine squared will give you 4 cosine to the fourth. So 4 times 2 will give you 8. So you have 8 cosine to the fourth theta times sine theta minus, oh, remember that's, well, I can leave that till after. Okay, minus, so if we plug in 0, we just get 0. All right. Oh, got to plug this in. It didn't look right. So if we plug it in here, we get 2 to the fourth power divided by 4. And then you have cosine to the 8th. So that gives us 4 cosine to the 8th power theta times sine theta. That's with respect to theta. All right. So now we go ahead and integrate these both with respect to theta. We're going to kind of work these two separate. Okay, so if u equals cosine theta, du equals negative sine of theta with respect to theta. Okay, so we end up with u to the fourth power, or the integral of u to the fourth, And the negative, we can just bring that out to the front. And that's sine of theta d theta. That's our du. That's negative u to the fifth over 5. And for this one here, to integrate this one, again, if u equals cosine of theta, we'll have u to the 8th. And we already have our negative sine of theta there. So that would equal u to the 9th over 9. All right, so if we go ahead and integrate this, we have negative 8 over 5. And we can just make it cosine to the 5th theta. Okay, since we use the negative for this one, that becomes plus. We have 4 times cosine to the 9th over 9. And that's from 0 to pi over 2. Okay, so we know that if we plug in pi over 2, cosine of pi over 2 is 0, and cosine of 0 is equal to 1. So when we plug in our pi over 2's, we just end up with 0 plus 0. We plug in our zeros, we end up with negative 8 over 5 plus 4 over 9. Okay, so if we distribute that negative, we have 8 over 5 minus 4 over 9. We go ahead and get our common denominators and add them together. We end up with 52 over 45. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our spherical coordinates. Okay. Spherical coordinate system. Okay, so before we jump into the examples, we'll kind of give a quick once over to our spherical coordinate plane. So let's say you have a point P in space is represented by an ordered triple. Let's clean that up a little bit. So you have rho, theta, and phi. Okay, rho kind of looks like a lowercase p. That's your theta, and that is phi. All right. Now, 1, phi is the distance between our point P and the origin. Okay. And P is greater than or equal to 0. Or phi is greater than or equal to 0. If you want, you can just write it as a phi. Okay. 2, theta is the same angle in cylindrical coordinates. Uh-oh, that a little bit closer. Coordinates 4 are greater than or equal to 0. So in other words, when your radius is greater than or equal to 0 or non-negative. Okay. Now your phi is the angle between the positive z-axis. Uh-oh, got a little, there we go. And the line segment from the origin to our point P. Okay, where phi is bigger than 0, but it's not bigger than pi. Okay, it won't always be pi, but it's just that it can be no larger than pi. Okay, so we're going to go ahead and give you a look at how that would appear graphically. All right, so the first thing you want to do is want to go ahead and draw our three-dimensional graph. Okay, so we have our x, bring that up a little more, our y, and our z. Okay, so let's say we have some value x, and let's say we have some value y. Okay, so this is, of course, the distance of our y, and this is the distance of our x. Okay, so let's say we have that point right there for our xy. Okay, going out to that point is some radius r. Okay. So let's say we take that point and go up the z-axis to right there. Okay, so we have x, y, and then we go right up to our point there. Okay. So for this point, from the top here, from the origin to that point, that's our P rho theta phi. Okay. Now our rho, remember, that's the distance between the point P and the origin. So this is our origin right here. Okay, our 0, 0, 0, that's our origin. So the distance from here to that point P is our rho. Okay, now our theta is the exact same as the cylindrical coordinates. It's the angle from our x-axis, our positive x-axis rather, to our radius. Okay, so that's our theta. All right, now our rho, which is a new one, that's the angle between the positive z-axis and this line segment. So in other words, the angle between here and here, that's our rho. All right. So you are still writing or drawing, feel free to press pause. But we're going to go ahead and continue on the next page because we have some conversion formulas to go over. Okay, now these come in quite handy. Okay, so if you wanted to convert from spherical to rectangular, you know that x will be equal to rho sine of phi cosine theta. Y is equal to rho sine of phi sine of theta. And z is equal to rho cosine of phi. Okay, now this is where theta 2 minus theta 1 is less than or equal to 2 pi. And 0 is less than or equal to your phi sub 1, is less than or equal to your phi number 2, is less than or equal to pi. Okay. Now, if you wanted to convert from rectangular to spherical, okay, you see here that rho squared is equal to x squared plus y squared plus z squared. Of course, we know our tangent of theta is equal to y over x, same as our cylindrical. And phi is equal to the arc cosine of z over the square root of x squared plus y squared plus z squared. Okay. So now if you wanted to go from spherical to cylindrical, of course, for our radius that's greater than or equal to 0, we have r squared is equal to rho squared sine squared of phi. Of course, our theta is just equal to theta. That doesn't change. And our z is equal to rho cosine phi. Okay, and if we wanted to go cylindrical to spherical, of course, for a radius that's non-negative, our rho will be equal to the square root of our radius squared plus our z squared. And our theta would just equal theta. And our phi will equal the arc cosine of z over square root of r squared plus z squared. Okay. Remember, your radius, r squared, is just x squared plus y squared. That would be r squared. So, if you ever need that little tidbit in order to convert, you want to remember that. All right. So if you are still writing, feel free to press pause. Oh, actually, we do have a little bit of room left, so we don't have to go to the next page just yet. So I can go ahead and write the actual triple integral for spherical coordinates. Okay. So if we have the triple integral x, y, z, respect to the volume. Okay, we want to start far left because this can kind of stretch out for a while. You have the integral from your theta number 1 to theta number 2. You have your phi number 1 to your phi value number 2. You have your rho value 1 and your rho number 2. That's a function of rho sine of phi cosine theta, rho sine of phi sine of theta, rho cosine of phi. That's times rho squared sine of phi with respect to rho, with respect to phi, with respect to theta. Barely able to get it all on there. Probably could have saved a little bit of space in between there, but with respect to rho, phi, theta. Okay, and that is where you just wanted to find the volume. That will be equal to triple integral rho squared sine of phi respect to rho, respect to phi, respect to theta. Right, so you don't have to actually put in your function when you're just looking for the volume. You just have to find the correct boundaries. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our example. All right, so let's say, for example, we want to convert the integral coordinates to cylindrical coordinates. Now we don't want to solve it, we just want to convert it. So we have the integral from -2 to 2. You have the integral from negative square root of 4 minus x squared to square root of 4 minus x squared. And we have the integral from x squared plus y squared to 4 of the function x respect to z, respect to y, respect to x. Okay, so we have our rectangular integrals. We want to convert those to cylindrical. So we want to have a z, r, and theta in any real order, since they're all the same. Okay. So the first thing you want to do, you want to jot down your cylindrical conversion. Remember, that's x equals r cosine of theta, y equals r sine of theta, and r squared equals x squared plus y squared. So now we want to take a look at our boundaries. So you have, starting in the middle here, z goes from x squared plus y squared to 4. So you have x squared plus y squared less than equal to z less than equal to 4. Okay, now going out a little more, the y's between negative square root of 4 minus x squared, and it's positive. So you have negative square root of 4 minus x squared less than equal to y is less than equal to square root of 4 minus x squared. And we see on the outside, the x is just between negative 2 and 2. Okay, so those are the boundaries that we have now. All right, so now what we have to do is we have to convert those to boundaries here. So let's say, I'm just going to write these in. Okay, remember that x is equal to r cosine of theta. So this will just be, let me write down the actual formula. So for cylindrical, okay, piece of 1, piece of 2, piece of 1, piece of 2. Let me give that a little more room. Okay, so that's h number 1, r cosine theta, r sine of theta, and h number 2, r cosine theta, r sine of theta. Okay, remember that's function r cosine of theta, r sine of theta, z times r, with respect to z, with respect to r, with respect to theta. Remember that r, don't want to forget that. Okay, so we want to go ahead and convert. I'm just going to go ahead and write our integrals here. Okay, so our f of r cosine of theta, r sine of theta, x, that's just x. But remember, x is equal to r cosine of theta. Okay, so since x is equal to r cosine of theta, you have r cosine of theta times r. Okay, so you have r squared cosine of theta. With respect to z, with respect to r, with respect to theta. And remember, you can put that in any order you like, as long as you have the correct boundaries here. Okay, so we want to go with respect to z. Okay, so remember, x squared plus y squared, that's equal to r squared. Okay, so our z can go from r squared to 4. Okay? All right. So now we can go to our respect to r. Okay, so if you remember, you have your radius, which will go here. So you have y is equal to r sine of theta. I'll put this right over here, just to. Okay. So that means your radius, since you have x squared 4 minus x squared, we know that has to be greater than or equal to 0. Okay, so that means x squared will be less than, I'm just going to switch that around, x squared less than or equal to 4. Okay, so that means that x is between -2 and 2. Okay, so we know that already just from here. Okay, so that means that our radius, remember your radius is greater than or equal to 0. So that means your radius has to be between 0 and 2. Okay, it's going to be that way for y. It's going to be that way for x. So actually, you can change that to your radius, since that's true for both the y and the x. Okay, so you also see it here. Z is less than or equal to 4. So x squared plus y squared would have to be less than or equal to 4. So we see here that our radius is between 0 and 2. Okay, so as you can see, that has to kind of make sense everywhere. Now, if you had a drawing or graph that accompanied the problem, that would help a lot. But since you're just going by what's seen here, that's how you can kind of work your way through it. But if you can somehow graph it, go online and find Desmos or something to graph the actual function, it would help a lot. All right, now for our theta, you can see here that because your theta, x squared plus y squared, we can see that's the equation of a circle. So at some point, because you do have x squared y squared, you're going to go from 0 to 2 pi. All right, so that's how you will convert to the cylindrical coordinates. Again, you're just going to take what they gave you and then kind of work your way around it. Like I said, if you can find a graph for it, that would really, really help. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. And once again, we're going to convert. But this time, we're actually going to follow through and solve it. Okay, so convert the integral. Okay, so we have the integral from -2 to 2. We have negative square root of 4 minus x squared to the square root of 4 minus x squared. And we have from 0 to the square root 4 minus x squared minus y squared of the function z squared times the square root of x squared plus y squared plus z squared with respect to z, with respect to y, with respect to x. Okay, you want to convert it from rectangular to spherical coordinates. And solve. All right. Okay. Now, once again, if you have a sketch, it really helps. Or a graph of your problem, it really helps. Okay, so this is a sketch of the region. Is helpful, but not necessary. All right. So first thing we're going to do is we're going to write down our boundaries. So we can see here that z is going to go from 0 to square root of 4 minus x squared minus y squared. Now for our y, we see that y is going to go from negative square root of 4 minus x squared to the positive. Okay, so y equals negative square root of 4 minus x squared to y equals positive square root of 4 minus x squared. And we see our x goes from negative 2 to 2. All right. Now, just to give you an idea of what this graph looks like, you draw your x, your y, and your z, it kind of looks like an upside down bowl, where the center of that bowl is going through the z-axis. So let's see if I can somehow draw that. Okay, so it kind of looks like that. Okay, where you have your center, and you can really go in any direction for your point P. You can go that direction, that direction, that direction, front, back, side to side, doesn't matter. Okay, so how do we know this? We know this because your z is equal to the square root of 4 minus x squared minus y squared, which means that 4 minus x squared minus y squared has to be greater than or equal to 0. So if you add x squared and y squared to the other side and kind of switch it over, that means x squared plus y squared is less than or equal to 4. So that lets us know that our region is a circle with the radius 4, not of the radius 4. With the radius 4. So our region that's shaded in, that's a radius of 4. Okay, so using this and the fact that we know that rho is greater than or equal to 0, because remember, rho is the distance from the origin to any point on that spherical looking object. Say rho is greater than or equal to 0, and we also know that rho is equal to the distance from the origin to the surface. Okay, so we know, since this is the region is a circle of radius 4, nope, that should be radius 2, because this is 2 squared. Okay, so that's a radius of 2. That means that rho is between 0 and 2. All right. So now we look at our phi. Okay. Now this is where the graph really helps, because remember, this is just the angle from the positive z-axis to the line segment from the origin to our point P. And remember that P could be literally anywhere as long as it's greater than 0. Okay, so that means this P we look at that value here, that can go from this side, or it can go all the way to the other side. So it can really go from one way or the other. It can go from 0 to 180 degrees, or from 0 to 2 pi. Okay, so that means our phi, I mean not 2 pi, pi over 2, because it's going in that way. Okay, I was kind of jumping ahead in my mind, because the 2 pi is when we get to the theta. Okay, now remember the theta is right up under there, where that's your radius. So your theta is the angle between your x-axis and that radius. Okay, now because that can go all the way around, because you have a circle, that's your 2 pi. I was kind of jumping ahead a little bit. Okay, so your angle equals, or theta equals the angle from x-axis to the radius. Okay, and that's where we get our 0 to 2 pi. Okay, so remember, for your phi, remember you're starting at, kind of move this out the way, your phi, you're starting at your angle here. So if you're starting at the z-axis, you can only go down pi over 2 in any direction. So phi would have to be between 0 and pi over 2. Whereas your angle, you go down to this point from your radius, that radius can go all the way around. So that theta can go all the way around. So it goes from 0 to 2 pi. Okay, so that, looking at this, and let me go back a few pages. Look at your, I'm going to cover this up for a second. Your original drawing for spherical coordinates, looking at this helps you understand. You have your phi, pretend that's a point on our graph. So we have our phi, that's our theta. Remember that theta can go all the way around if you have a circular region, which we do. You have a circular region, so that theta can go all the way around. Phi is just that distance. I mean, rho is that distance, and our phi is the angle from rho to that z-axis. All right. So what we're going to do now is we're going to take all of those new boundaries and create our new triple integral. All right, so if you remember, you have your, just write down the formula. You have theta 1, theta 2, phi 1, phi 2. You have rho 1, rho 2, the function of rho sine of phi cosine theta. We have rho sine of phi sine of theta. We have rho cosine of phi. Remember, that's phi squared sine of phi, respect to rho, respect to phi, respect to theta. Okay. So once again, we were able to squeeze all of it in there. Okay. Now, if you remember, your function here is actually z squared. Oh, let me bring this down some. It's actually z squared times the square root of x squared plus y squared plus z squared. Okay, so this is actually z squared times the square root of x squared plus y squared plus z squared. So now we have to convert this. How do we do that? Well, we know that two things are for sure, and I'll put that right here. Okay, we know that z is equal to rho times cosine. That means z squared will be equal to rho times cosine squared of phi. Okay. We also know that rho is equal to x squared plus y squared plus z squared. Well, rho squared is equal to that. But if we square root both sides, we know that rho is equal to the square root. Clean that up. X squared plus y squared plus z squared. All right, go back to the pages and I'll show you exactly where I got that from. Okay, go back to your conversion page. Just going to cover this up for a second. Okay, so, remember that z is equal to rho cosine of phi. So that's where we got the z squared is equal to rho squared plus cosine squared. All right, and here it is. Our rho squared is equal to x squared plus y squared plus z squared. So if we square root both sides, rho is just equal to the square root of that. So that's where we got those two from. Okay. So that means our z squared, that's going to be rho squared cosine squared of phi. All right. And our square root of x squared plus y squared plus z squared is equal to rho. That's rho squared cosine squared of phi times rho. You don't really need the parentheses if you don't want to put them there. I just kind of put them there to kind of separate it. Times, thing is, it's still multiplied by rho squared sine of phi. That doesn't go anywhere. That's multiplied to whatever this becomes. So you're going to multiply it by that. All right, so that gives us, go ahead and just write those three integrals there. We have rho squared times rho, which is rho to the third, times rho squared is rho to the fifth. We have rho to the fifth times cosine squared of phi times sine of phi with respect to rho, with respect to phi, and with respect to theta. Okay, so you know your rho, that's from 0 to 2. You know your theta, no, your phi rather, is from 0 to pi over 2. And we know your theta is from 0 to 2 pi. Okay, so that's how you would convert it, but we still have to solve it. Okay, all of that was just to help explain how you would convert it. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and finish converting it on, not converting it, solving it on the next page. All right, let me write down where we left off. So from 0 to 2 pi, 0 to pi over 2, 0 to 2, rho to the fifth power, cosine squared phi, sine of phi, respect to rho, respect to phi, and respect to theta. There we go. Excuse me. All right, so we go from 0 to 2 pi, because we're going to start, of course, in the middle. 0 to pi over 2. Okay, so if we integrate this just with respect to rho, remember these two will be considered constants. So we just integrate the rho, which is rho to the 6th power over 6. So you have rho to the 6th power over 6 cosine squared phi sine of phi. And that's from rho equals 0 to 2. Respect to phi, respect to theta. Okay, so if we plug in 2, we have 2 to the 6th power, which is 64. So we have from 0 to 2 pi, 0 to pi over 2. And we have 64 over 6 cosine squared of phi sine of phi. And if we plug in 0, that just gives us 0, so we don't have to worry about that. And that's respect to phi and respect to theta. Okay, so now we go ahead and integrate with respect to phi. Okay, so that's 64 over 6. If you want, you can bring that on the outside. But to integrate this, remember, you make u equals cosine of phi. And our du is equal to negative sine of phi with respect to phi. So that means if we integrate our u squared, because remember this is just u squared, and that negative, we can pull that right out to the front, negative u squared du, that would equal negative u to the 3rd over 3. So that would be cosine to the 3rd over 3, or negative. So that's the integral from 0 to 2 pi. And 64 over 6, that can actually be simplified to 32 over 3. So you have 32 over 3 times, you have negative 1/3 cosine to the 3rd. So negative 1/3 cosine. I don't really need parentheses, we can just put phi. And again, that's from 0 to pi over 2. And that's with respect to theta. Okay. So, from 0 to 2 pi, and I'm just going to go ahead and put the 32. Well, we have negative 1/3. Well, I'm just going to leave that there. So we have 32 over 3. We have, if we plug in the power over 2, we get cosine of power over 2 is 0. So that's just 0 to the 3rd power. So we have negative 1/3 times 0 minus negative 1/3. Plug in 0, we get 1. So negative 1/3 times 1. Respect to theta. Okay, so this just ends up being 0 plus 1/3, which is 1/3. Okay, so that 1/3, we can just factor that right on out. So 32 over 3 times 1/3 is 32 over 9. Okay, where we still have to find the integral from 0 to 2 pi, really just 1. So that with respect to theta, we end up with 32 over 9 times theta, and that's from 0 to 2 pi. Okay, so we plug in 2 pi, we get 2 pi. We plug in 0, we get 0. So that ends up giving us 64 pi over 9 as our final answer. Okay, so that's how we would convert to a spherical triple integral and then solve. All right. So hopefully this video made sense, and I'll see you on the next video.